Hi everyone, welcome back to the AI language. So today we are going to implement Google sign-in for our MCP clients and servers. So the users will be able to sign in to the MCP server through the MCP client using Google sign-in. All right. And that's a very simplified way of putting it. And I'll actually go into details as I go along in this video. But let's start with our multi-agent MCP plus A2A system that we have been building in our masterclass. If you haven't had a look at it, please have a look at it where we coded this entire system from scratch. To understand authentication, we'll remove most of the complexities in this system. All right, we'll just focus on the MCP client and the MCP server. But just to give you a brief recap of what this system was and what are we going to focus on, let's just briefly understand that we have a user who's using some kind of an app on the front end, right? And what we did was we connected it using an A2A client to an orchestrator agent. This is a part of a multi-agent system, and what this orchestrator does is that it receives the user input. It decides what kind of tools from the MCP side, which is this green branch, to use, if any, or it decides to delegate the task to another agent in this red branch, which is the A2A agents branch. All right. Now, since we are talking and focusing on authentication for the MCP client and server, we are going to focus on the green branch over here. So the orchestrator uses something called an MCP connector that we developed. It lists all the servers in a config.json file, then uses a client to access those servers and get all the tools. All right. And this way our user is going to provide an input and the orchestrator will be able to use the MCP server. And this is what we've already coded. So we already did this in our masterclass, but we did not have any authentication over here. All right. So what this means is that the user can authenticate himself or herself using the app front end, but our host agent had free access to this server. All right. Now, the true power of MCP lies in the fact that anybody can make an MCP server and connect it to any kind of a client or an orchestrator, any other, MCP client or agent, right? So in that sense, let's understand that if there's an MCP server developer, they might want to enforce authentication. They might want to say that you can use the MCP server and tools, but these are protected. All right. So this is something which we call as a protected resource server. And now what happens is that as a server developer, you can develop your server, you can provide that information about authentication inside the server itself, and then you can leave it open for anyone else to integrate it. You'll always show that the user will come through and authenticate themselves using some kind of an authorization server. In our case, we're going to do it with Google. And then the server will be sure of the identity of the particular user. Once the server is sure of the identity of the user, it can authorize access to certain tools or it can limit access to certain tools. And that is why this authentication is important. All right. So since we're going to focus on this particular part, which is the MCP branch over here, let's zoom in over here and let's look at the key components. So we are going to be working with an MCP client that's going to connect through the model context protocol or MCP to MCP servers. We're going to call this server as a resource server because it has some resource that we want to access through MCP, and that's a protected resource. So in this case, we'll have some tools and the tools will only be accessible to users who can identify themselves using Google Sign-in. All right. So that is that. There's going to be two more components. One will be the user. So we can actually go over here and we can see that there's a user over here, and there's going to be an authorization server. All right, which is going to authorize the MCP client for us. All right. So now that we understand that there's this multi-agent MCP plus A2A system that we built, and we are focusing on authentication over here between the client and the server, let's move to now a specific sequence diagram that details all the steps in this authorization. And this diagram basically outlines all the steps that happen in the authorization flow. So we already went through the details of this diagram and each step over here in the last lecture. And just to give you a quick recap, we have four different entities over here. So we have the user over here, and we already looked at this user in our architecture diagram in the previous slide. So this is the user over here. Then we have the MCP client over here, and this is the client that's going to connect to the MCP server using the MCP protocol and authorize itself this time. It's not going to be available openly to all kinds of clients. All right. And finally, there's the fourth component over here, which is the authorization server. And this is a server that will authorize this particular client and user to access this MCP server. All right. So let's start with some basics now. So why do we need the authorization server? So we need an authorization server like Google because the client itself represents a user and they have, let's say, a Google ID and password, and they don't want to provide that ID and password to the server itself. All right. So what they're going to do is that they're going to provide this Google ID and password to Google, which is going to be the authorization server over here. And then Google is going to provide a token to this client, which will identify the client and say that, this is an authenticated client. And then this client is going to use that token to connect to the MCP server. The MCP server will check this token to be valid with Google. And if it is valid, then it is going to provide access to the tools. Why do we need to use Google as an authorization server? Because we could build our own authorization server, but that is not a trivial exercise to do. And there's a lot of security considerations that you would have to keep in mind to build that. So we're not going to go into that. All right. All right. So, and these are all the steps that we would have to implement. But luckily, what we'll do is that we'll not go through implementation of all these steps, because not only is the authorization server a non-trivial implementation, even the implementation of all this back and forth that happens between the client and the server is a bit non-trivial. All right. So, and these might keep changing as MCP develops. So let's use a library. Let's use some kind of preset library that can help us with this. And for that, we're going to use something called Fast MCP. All right. So you might have heard of Fast MCP before, and this is also a part of the MCP protocol, but we're going to use a later version of this, which is version 2 onwards. And this actually is not part of the MCP protocol as of now. It might become a part of it later on. But as I understand, this is a standalone library, and you can find this on gofastmcp.com/server/auth/OAuth Proxy. So what we're going to do is we are going to use the OAuth Proxy pattern. All right. This is one of the patterns that is used to implement this kind of a authentication flow over here. So why are we using Fast MCP? We are using that because one of the reasons that I already told you was that Model Context Protocol is a new protocol. It keeps on updating, right? And the requirements for the Model Context Protocol, the interactions with the OAuth provider, the interactions between the client and the server might keep on changing. So it's good to have a well-maintained and stable solution like Fast MCP. At least we expect it to be well-maintained and stable, right? That updates according to the changes in this protocol. All right. So we don't have to then granularly code all these interactions. And if they change, we don't have to keep on updating our code because of that. All right. So that's one. The second thing is that the OAuth providers like GitHub, Google, etc. have certain requirements for OAuth. All right. And the MCP clients expect some other requirements to be satisfied, which are slightly different. So one example is dynamic client registration. So providers like Google do not support dynamic client registration. We had looked at this in our last lecture. And what MCP or Fast MCP does over here is it bridges that gap. It facilitates the client interactions with the OAuth provider through its own server over here. And this then works on our resource server or our MCP server itself. All right. So Fast MCP will work on our resource server and MCP server. And this is going to then act as a OAuth proxy between the client and the OAuth provider. So that's a difference between what we see over here. This is going to be slightly different from what we saw over here, where the client actually directly interacts with the authorization server over here. Okay. So that's slightly different, and we're going to use the Fast MCP library to help us out over here. So before we start implementing this, you would have already set up your Google Cloud project, right? So we did this in our last lecture, and we set up a Google Cloud project, and we went to APIs and services. And over here, we completed the configuration of our OAuth consent screen, and we set up credentials over here for our Fast MCP server, right? And these credentials provide us something called the client ID and client secret, that you're only able to download once, and once you download them you can actually save it in a file, and I'm assuming that you have already done that. If not, please refer to the lecture that I have described or I've given the link for in the description. This should be the previous lecture in this course. It's a pretty simple short lecture where you can actually set this up. All right. So this is the first requirement that we need to do. Let me click on the Fast MCP server to show you two changes that I have made to this. So I've set the port to 8005 because of a conflict on the previous port that we had set over here. So please use 8005 over here to follow along with me. You can update your configuration if you already did this. And the second change that I have made is that I have added the local host and 127.0.0.1, both of these as authorized redirect URLs and authorized JavaScript origins. All right, because some of the machines actually use localhost, some might resolve localhost to 127.0.0.1, and I don't want Google to reject or these origins or these redirect URIs. All right, so that's that. The other thing that I've updated is on the data access. So you need to specify what is the data access that you want. So you need to specify scopes, and scopes express the permissions you request to authorize for your app and allow your project to access specific types of private user data from their Google account. All right. So I have added some non-sensitive scopes over here. So these scopes are auth user info email, auth user info profile, and open ID. All right. And this is the description for them. You can have a look at this, and this basically provides access to basic user details like email address and profile information from Google. And once we add these data accesses over here, this means that once the user authenticates with this authorization server, we'll have access to these details from the user. All right. All right. So to add these, you can click on add or remove scopes, and you can search for OpenID, profile, and email. Once you get that, you can select them and you can add them. All right. You'll see this table over here, and you can actually just check mark these over here as well. So please add them and click on update over here before proceeding. So once you've done this, your authorization server setup is complete. Now let's move to the code. For the code, we're going to make this a part of our MCP streamable HTTP implementations. All right. So you'll see that we have a root folder, which is called MCP streamable HTTP. And then we have a folder for our server. So that's called streamable HTTP server. Inside that, we have the older implementation, which was the stateless streamable HTTP server. And now we have a second implementation over here, which is Google OAuth simple server. All right. And this is a server that we have built for our resource server or MCP server that uses Google's authentication. And then we also had a universal client folder over here. Inside that, we had built two kinds of clients, the Google ADK Gemini MCP client and the ADK web client. But now we are going to add a third client implementation, which is Google OAuth simple client, which is an MCP client that uses the Google based authentication. Now, these are independent codes, so you can run the client, which is under 3 Google OAuth simple client independently, and you can run the server independently, even if you have not looked at these previous codes. Although I highly recommend that you look at these previous codes just for those specific implementations if you are interested in that. All right. But this is a different implementation where we are going to make a streamable HTTP server, which is this server.py file. And then we are going to use Google's authentication or OAuth system, and we are going to authenticate a client and access the tools on this server. All right. So that is how the code is structured. Now I'm going to start with the client implementation over here. Okay. So let me zoom in over here, and you can see that this client.py file is a minimal MCP client that authenticates to your MCP resource server. So our MCP resource server is the MCP server itself. It's called a resource server because it offers a resource, which is the MCP tools. All right. And we're going to use the Fast MCP OAuth Proxy flow. We've already looked at this before. We've looked at PKCE earlier, and we've also looked at the loopback redirect. And then it calls two protected tools, get user info and get time. So these two tools are what is offered by the server. So just so that we know that we have authenticated successfully, we can call a tool called get user info, and this is going to tell us the user's information like email ID or profile information using the authentication token. All right. So if you're able to get this successfully, basically we have tested this to work properly. All right. Okay, and just in case you need more information on PKCE and loopback redirect, please look at the previous lectures in which we have covered the authorization overview, where we talked about all the steps that happen between the client and the server. All right. Now let's go down to the code. You can read through the comments if you like, but I'm going to go back to the main function over here. Go down to this main function, and we're going to start with this. All right. So first we are going to configure the OAuth helper. We have the MCP URL. So this is the MCP endpoint on your RS proxy. All right. So what does this mean? RS is the resource server, which is your MCP server. It's also an OAuth proxy for our Google Authorization Server, right? And the MCP endpoint is the /MCP endpoint for that. So we are going to use localhost :8005. That's going to be our base URL. And the MCP endpoint on that will be the /MCP after that. So then we have the scopes. So these are the requested permissions. And over here we have specified OpenID, userinfo.email and userinfo.profile. And this is what we also configured in our Google credentials. All right, so that is the basic configuration for the OAuth helper. So this is a helper. And now we are going to create a client. So we'll open a session to the MCP server. And this client manages a streamable HTTP session with your MCP server, which is the RS. So please remember that whenever we use the term RS over here, we are referring to our MCP server, which is the resource server. We pass the OAuth helper in the auth property over here, and this basically wires in the OAuth flow, which was described above. So now this is as simple as it gets on the client side, that you just specify this OAuth helper, which has your URL and your scopes. And when you specify this over here, the client automatically then manages the OAuth flow on its side. And once we define this client over here, this initiates all the authorization flow. Whenever this is done, it basically means that you have authenticated with Google. So we're going to print authenticated with Google over here. And then we're going to discover the tools. So we'll say tools is equal to await client.list tools. And then it's going to print the tool names over here. And after that, we are going to call a protected tool. So we're going to call the tool called get user info. So we'll say client.call tool with get user info, and we'll get the result over here. We have a helper function above which converts this to JSON. So you can have a look at that, but it's a simple parsing function, and we are essentially printing the result that we have gotten over here in the form of a JSON. We say user information is information, and then we use info.get email and info.get name over here. All right. Finally, we call another protected tool, which is get time. And once we do that, we can actually again print the time based on the tool's output. And finally, we explicitly close the session over here. And we have the main entry point over here that when we run this, it's going to run the main function above. And there's a exception management over here, that in case the session termination failed, and that was the exception, we ignore that. All right. Otherwise, we raise the exception. And this is mostly benign as far as my understanding goes, because some MCP clients, may log session termination failed because the server side session was already cleaned up before the delete /MCP happens in this flow. So when that happens, your client is trying to close the session, but it's already terminated, and you might get this kind of a session termination failed error over here. Okay, so we just ignore that for now, right? And we capture this in this exception management over here. Okay, so that's your client code. Now let's go to our server code. Now this is our server code, and the purpose of this is that it basically starts a model context protocol resource server, or RS as we were calling it. And this is protected by Google OAuth 2.0. All right, and this demonstrates a complete standards aligned flow where your client, so for example, we can have Cloud Desktop as our client, or we can have the client.py file that we just looked at. So this first hits the protected MCP endpoint and gets a 401 with www authenticate header. All right. The header points the client to this server's protected resource metadata. And you can go back and look at our sequence diagram. Let me just quickly go back over there. Yeah, so this was our sequence diagram originally, and you can see that this has this logic that you hit the MCP server without a token, you get the unauthorized response with the authenticate header, and this will have a resource metadata URL inside this header, and then you request the protected resource metadata. So all these steps are happening, and these are happening based on the implementation that we are doing in our server.py file and our client.py file. So going back to the code over here, so the header points the client to this server's protected resource metadata, and this lists the authorization server. All right. Now, this process includes dynamic client registration, DCR. All right. And it also includes PKCE, which we saw earlier, and a resource indicator, that is the exact MCP URL to bind the tokens. All right. The server then proxies OAuth to Google. So it sends the users to Google's login consent screen. It receives the code on /auth/callback. This is again a URL that we have configured in Google. Then it swaps it for the tokens and validates the access tokens against Google's token info. Okay, so these are all the steps that are happening, and these are the steps that we have discussed in our authorization flow earlier on. And this is slightly different from that in the sense that you have a OAuth proxy over here. The RS acts as a OAuth proxy. All right. So you can think of this server as both the resource server that hosts the protected MCP endpoint, and it's also a local authorization server facade, such that the MCP clients can discover and speak to using the standard OAuth, DCR, and PKCE, while we in turn delegate to Google behind the scenes. All right. And the important things to note over here is that the resource string must exactly match. All right. So there can't be an MCP trailing slash at the end, because that will break it. And Fast MCP stores all your caches and tokens over here. So in case you have some kind of an error happening, please do try to clear the local cache, because that will clear all the existing tokens that have been stored over here. And then there are test endpoints. So you can test these requests using curl if you want to. And I'll show you how this works, but you can actually hit these endpoints over here to understand what is the response that the server is giving. All right, but let's go to the code first, and then we are going to test it out. You might have noticed that I'm not using the MCP package over here. I'm using Fast MCP. This is a different package and not part of MCP. All right. All right. So first we'll load our environment variables file, and we'll have a look at how we have defined everything in the environment variable file. But we're going to get these particular variables over here. So the first thing is you're going to get the base URL. All right. And the base URL is going to default to HTTP localhost 8005. Then we're going to get the hosts. The host is going to be 0.0.0.0. And this is basically to listen on all interfaces. And this is fine in the development environment. And the port defaults to 8005 over here. All right. Then we have the MCP path. So this is basically telling us the exact path segment under the base URL, that is the protected MCP endpoint. And that's going to be /MCP. And this string becomes the resource indicator. So this tells you where does your resource lie. And you have to make sure that you are consistent in how you specify this. If you choose /MCP, then everywhere metadata, clients, and resource parameters, etc., you must use /MCP only. Don't use an ending slash. So don't say /MCP and then another slash after that. All right. Then you have the Google OAuth app credentials. So you have the client ID and you have the client secret. And this is what you get when you configure the consent screen and the credentials on the backend with Google. So you'll save this in an environment variable and get it from there. There's no default for it because we do need to save it in the environment variables, right? Then you have a redirect path. So this is the path on this particular resource server, right? So this is the server where Google will redirect the user back with the authorization code. So if you remember from our authorization flow steps, there's an authorization code that you get back from Google after the user authenticates themselves with Google, right? So that authorization code has to be captured by our server or by our client. So we use the /auth/callback endpoint or the path on this particular resource server, and this is where Google will redirect the user back with the authorization code. And you must register this full URL, the base URL plus redirect path, in your Google Cloud Console OAuth client. And we've already done that and we've seen that. All right. Now we have the scopes over here. So the required scopes, we'll try to get this from the environment variable. Otherwise, this is the default over here, which is the same that we looked at before. And we are going to put this under required scopes. Then we have the allowed client redirect. So what happens is that in dynamic client registration, we need to allow the MCP clients to dynamically register loopback redirect URIs. All right. So what this means is that the MCP client is going to spin up a small server, and that is where it is going to capture the authorization code that has come from Google. It went to our resource server on this auth callback URL over here, and finally the client captures it over here. So the client, when it spins up and connects to the MCP resource server, it's going to provide this URL to our RS and tell that, this is the kind of URL where I'll actually receive back the authorization code. This is basically the loopback redirect URI. All right. And as mentioned over here, MCP clients typically spin up a small local HTTP listener on a random port. Now, this is one issue why we need the proxy with the RS in between, because the MCP client can spin up a URL, but Google needs a fixed URL. Whereas the MCP clients, there might be several clients that you can work with when you're developing a server. Each might have its own port, its own format for a URL, right? So the RS stands in between Google on one side and the MCP client on the other side. It provides the auth callback URL that we saw above, which is fixed and which we have registered with Google Cloud Console's OAuth client, right? And this allows you to provide a pattern for the client. So you can say that I allow this kind of a URL from the client. So the client is going to give localhost : some random port number, right? And we permit the localhost patterns by default. In production, you will lock it down to a specific domain, right? You might say that whatever is the domain from the client, etc., you might lock it down, and you lock it down to maybe a particular port as well. But you don't need to register all of them with your Google OAuth client. You can just lock it down inside this server definition. Okay, so this is basically the allowed client redirects. And finally, we have a resource variable over here, which is just your MCP path, the entirety of the MCP path. And this must match how clients connect. So we expose it in .wellknown /OAuth protected resource. The clients will include this exact value as the resource parameter in their authorization request, so that Google issues a token bound to this particular resource. All right. And again, do not add a trailing slash. This is very important because, once you add it anywhere in your code, you'll get errors because of the mismatch, and it's pretty difficult to otherwise debug those errors because it's just been a simple, extra slash somewhere in the code. All right. And now we use the GoogleProvider from Fast MCP. So the beauty of using the Fast MCP library is that all this logic of interaction between your client, your resource server, and the proxy, and the Google Authorization Server is wrapped up in this simple definition of a GoogleProvider. So we construct this GoogleProvider. This single object publishes the Authorization Server metadata on OAuth Authorization Server. It provides the /authorize /token /register endpoints. It manages PKCE and DCR. It talks to Google for user login and token validation. And it integrates with Fast MCP, so the protected /MCP endpoint knows how to challenge clients and verify their bearer tokens. All right. So all this logic and the complexities of this logic have been discussed in the previous lecture on the authorization flow. So please refer to that if you want to go into more details on these. But for now, we're just going to say that we have a GoogleProvider. We provided the client ID, the client secret. We provide the base URL, which is localhost 8005. We provide the redirect path which is auth/callback. We provide the required scopes, which is OpenID, profile, and the email. And then we provide the allowed client redirect URIs, which is the local host :* and the 127.0.0.1. All right, from here. All right. So next we create the MCP application. So we'll use MCP equal to fast MCP. We provide a name. So MCP RS with Google OAuth. And then we provide the instructions. So this is protected MCP server that delegates OAuth to Google via DCR capable proxy. And then we provide the auth equal to Google OAuth over here, which is a GoogleProvider. All right. So the name and the instructions appear in client UIs, and this is just friendly branding over here. And the auth equal to Google OAuth wires in the auth provider. So you have all these endpoints baked into your MCP server automatically. All right. Now we can just define the tools over here. So these are protected MCP tools. Any tools that you define over here would be protected. And this decorator MCP.tool, of course, we have seen this before, and it registers a tool callable over MCP. Because the MCP endpoint is protected, calling this requires a valid Google bearer token. So if anyone just signs in using Google, this server will allow access because it's just made to do that. You might put additional steps. So you might say that, some email IDs are allowed, some email IDs are not allowed, and so on. So you can do all that. But we will just ask the user to sign in using Google. And if they do that, we have a valid Google bearer token that we get. We'll allow tool execution. Okay. So this is the get time tool, just simply returns the time. Again, I'm not going to go into the detail of this tool over here. The main aim is to understand how we are providing authentication over here. All right. The second tool is the get user info. Okay. And this is another protected tool. Again, it's not that we have done something specific to protect this tool in the tool definition itself. Just the fact that our MCP server is defined using a Google OAuth provider protects it, because calling this tool or sending any request to this server to run this tool will require a valid Google bearer token. So this tool actually demonstrates reading the verified token claims as provided by the Google provider after validation. So whenever the client hits the server to call this tool, it will send in a token, and what we'll do is we'll use the token, we'll retrieve the claims from that. All right. So Google will have things like, subject, email, name, picture, locale, etc. And you can print these out. If you can print this out from the validated access token, it means that you were able to identify the user and validate the token as well. So we grab the verified token object using this, and then we use token.claims.get, and then we can get these pieces of information over here. You might need to actually call more endpoints on Google's end to get more information if you would want to. But all this just shows that, we have a validated access token, and we can get user information from that. And, we can use that to actually then further restrict what tools are allowed to be called, what tools are not allowed to be called, and so on. There's an unauthenticated health check over here, and this is handy for readiness probes. So we define an MCP custom route over here that can actually return a JSON response with all this information over here. So this is our entry point. Start the HTTP server and mount the MCP transport. So if we don't have the Google Client ID or Google Client secret, we are going to raise an error and exit. Otherwise, we're going to log in all the information over here. So we're going to log this information and print it out. Then we're going to start the server with the streamable HTTP transport, and this will expose all these endpoints automatically. And we're going to call mcp.run with the transport specified, host, port, and the MCP path specified over here. So this is a quick test and debug guide, and we're going to follow this to test out our server. All right. Let me actually give you a demo of how this works. All right. So let me zoom out over here and let's open the terminal. All right. So here we have the terminal. Now, what will happen is that once you download this code, you'll get the pyproject.toml file. And this already specifies all the dependencies for this project. Note that we have provided fast MCP from source. All right. So we don't want to depend upon the package management of UV over here to get the source. We have actually specified the Git address for it so that we get the latest version where we have the Google providers, etc. specified and defined properly. right? So that's the fast MCP source. And once you have this, you can just simply go over here and type UV and then space venv. So this is going to create a virtual environment for you, right? I already had it created, but I've just created it again to show that to you. Then we can just type source.venv/bin/activate. So this is going to activate the virtual environment over here, MCP streamable HTTP. And now what we're going to do is we're going to actually sync all the dependencies using the pyproject.toml file. So we're going to say uv sync, and let's write all groups over here. So this is going to just sync all the dependencies. So now we have all the dependencies synced, and now we can simply run the server. So this is simply run as uv run, and then we provide the server path. All right. So let's provide the streamable HTTP server path. We know that it is the second server that we have, and then we have the server file, so server.py, and then we just press enter. Okay, and you can see that I have 8005 already being used, so I'm just going to terminate that process. I already have this server started, so let me just actually restart it on that port. Okay, so if you have something else running on that port, please shut that down, and you can then start the server again. And once you start this server, you're going to get a screen like this. Let me just expand this. So you're going to get Fast MCP 2.0, and you have the server name, you have the transport streamable HTTP, you have the server URL over here, and you have the Fast MCP version, you have the MCP SDK version, docs, deploy, etc. And then you can say that MCP RS with Google OAuth. So this is the name that we gave it. All right. So now this is running. Let's now open a new terminal window. All right. All right. So we already started the server. Now let's hit this endpoint and see how it works. Okay. So I'm going to paste this over here. So I've pasted this over here, and let's press enter. So now you can see that when we hit the MCP endpoint, we get unauthorized, which was the expected response. And we get authenticate header as bearer, error equal to invalid token, error description is that authentication is required, and we get the protected resource metadata. That is what the flow request requires, right? So we have localhost :8005/.wellknown /OAuth protected resource. So now we can hit this endpoint to get the protected resource metadata. All right, so that is done over here. So let's do that. So let's copy this command and let's paste this curl command over here, and let's hit this OAuth protected resource endpoint. And once you do that, you get the these parameters, right? So the most important thing over here is that you get the scopes and the authorization server URL. So basically our resource server is telling whoever is trying to access it that in case you want to authorize yourself, hit this endpoint, right? And these are the scopes that we support. This is the kind of data you can access, right? And the bearer methods that are supported are header, so you need to support that particular method. And the resource that you're trying to access for which you require this authorization is the server's /MCP endpoint. All right. So the /MCP endpoint is the one that is protected. So now we can actually hit the authorization server metadata. So let's just do that now. So I'm going to copy this and let's paste this curl command. So now we can see that we are using localhost 8005 as the authorization server, and we're going to hit the OAuth authorization server endpoint now. All right, so let's press enter. Once you do that, you now get the information about the authorization server. So it says that the authorization endpoint to authorize is /authorize at the end. It also gives a token endpoint, a registration endpoint for DCR. It again lists the scopes. It provides you the response types that are supported, which is the code, and then the grant types that are supported. It also gives some other information around auth method supported and the challenge method supported. And we looked at the challenge methods and other details in our authorization flow discussion that we did in the previous lectures. Okay, so this is what your client is going to do internally. For now, we're just testing it out using curl so that we can see the entire flow in action. All right. So now that we've seen all this, we can actually go ahead and run the client. All right. So I'm going to write uv space run, and then we're going to specify the client. So that's in the universal client folder. So let's do that. And then we have client number 3 that we have built for this. And then we simply have client.py, and let's press enter. So once you run this client, it says authenticated with Google and it actually prints out all these things over here, right? Now it's able to do that because it's actually saved the previous token when I authenticated with Google inside the local cache. So I'm actually going to clear this just to show you the entire flow. And to do that, let's just type rm-rf, and then we're going to use the user home directory, and then we have the fast MCP folder over here, and then we have the auth MCP client cache, and then we have the HTTP localhost 8005, and you can see that there are two files over here, info.json and tokens.json. So I'm going to delete both of them. I'll just put a star over here, and now this should have been deleted, and now I can run the client again. So I say uv run, and then I'll provide the path to the client and press enter. Now this is going to open the browser for me with sign in with Google Flow. All right. So let me first show you the console over here. So if you can see, there's the OAuth authorization URL over here, and this is on localhost colon 8005/authorize. And then it has the response type, it has the client ID and so on. It also has the redirect URI, which is 64813 and then callback. And you can see that the OAuth callback server is running on that same port. There's a code challenge over here. There's a code challenge method over here. The resource is specified over here on localhost 8005 and so on. And you also have the scopes mentioned over here, right? So this is the complete authorization URL, and this is what is opened in the browser. The OAuth callback server is running over here, which will receive the authorization code once you authorize. And now we can actually head to the browser and sign in. So if you see over here, you are on accounts.google.com/o/OAuth2 because we have been redirected over here by the authorization server, and you can actually look at this in this screen. So you can see over here that our MCP client first hit the MCP endpoint, received the 401 unauthorized, then it hit the OAuth protected resource endpoint, that was a 200 OK, and then we had the OAuth authorization server endpoint, and then it registered itself, and then it's called the authorize URL over here. Once it tries to open this URL, our server will redirect to accounts.google.com, which is the actual Google authorization URL. So that's where we are actually authenticating. And now you need to log in through your Google account over here. So I'm going to do that. All right, so once you authenticate over here, you get a confirmation screen like this. So let me just zoom out and show you how this looks. So it just says authorization successful, authentication successful, and you're connected to localhost colon 8005 because your client thinks you're connecting to localhost 8005, and actually the resource server is acting as a proxy. You're actually signed in using Google now to this server. All right, so you can actually close this browser. As it says over here, you can safely close this tab now. So let's close that. And now let's go back to our client. So if you go back to our client, let's zoom in over here. So just for the demo purposes, I have replaced this with some dummy values over here. So you basically get authenticated with Google. So you were successful in authenticating with Google. You get the tool names over here, get time and get user information. And then you have the user information, which is the Google ID, the email, the name, picture, locale, etc. And so you have the Google user, the name. We have the current time as well, so we were able to call the get time tool as well. And finally we have this supposedly benign error over here, which is session termination failed at 404, and we are back at the prompt. So this is a complete example of an MCP client and server working together and using an OAuth proxy pattern, and then using Google as an authorization server to authenticate the client to the server and accessing protected resources on the server. And this basically completes the entire demo. Now, a couple of important points that you should take care of. One important point is that this is an example using the Fast MCP library, right? As MCP develops, there might be several providers who provide these kind of libraries to facilitate the interaction between the MCP client and the authorization server and the RS, right? So you might decide to use any one of them. I have chosen Fast MCP because it seems to be one of the most stable and well developed, MCP wrappers out there, which then provides us with this, simplified interface to implement all this OAuth proxy back. All right. So that's one. And if this changes, please feel free to understand this concept first and then use any other library that you might want. All right. The second thing is there's also a way to actually implement the full OAuth flow on your own. All right, where you will actually develop your own authorization server. You might see this in some examples, but I'll actually go back to one of the lines that I read on Fast MCP. All right, so I'm back on gofastmcp.com, and you can actually go to servers, then authentication, and you can go to full OAuth server over here. And this is what actually they also specify, that this is an extremely advanced pattern that most users should avoid, because building a secure OAuth 2.1 server requires deep expertise in authentication protocols, cryptography, and security best practices. And so this complexity extends far beyond initial implementation to include ongoing security monitoring, threat response, and compliance maintenance. All right. So you can use remote OAuth instead, unless you have compelling requirements that external identity providers cannot meet. All right, such as air-gapped environments or specialized compliance needs, etc. Okay, so my recommendation would be that you used something like OAuth Proxy. There are other patterns as well over here. You can look at those. But what we have just done is we have used OAuth Proxy over here to authenticate with Google, and then use that token to authenticate to our MCP server, which acts as a proxy between the client and the Google Authorization Server. All right. So one more file that we need to look at is the environment variables file. So this environment variables file is over here. You can actually click this over here, and then let's see what all variables we have defined over here. So over here we have the MCP resource server with Google OAuth and all the details around it. So we have the resource server based URL, so that's localhost 8005. And then we have where to bind the local server. So we have the host 0.0.0.0, and we have the RS port, which is 8005 again. Then we have the path where the MCP endpoint is bounded. So that is /MCP without a trailing slash. Then we have Google OAuth client credentials from Google Cloud Console. So we have a client ID and we have a client secret. I'm going to delete this as soon as I release this video, but this is something to be kept confidential. And just in case you notice that this OAuth proxy pattern actually keeps this client ID and secret on your server, right? So you're not exposing this to all the other MCP clients, which is a good thing, right? And then you have the redirect path you registered in Google Cloud OAuth credentials. That's /auth/callback. This must match exactly, and just like the other URLs. And then you have the required OAuth scopes. So this is a space separated list over here, and we specified this over here. We also have a lot of these specified as defaults inside the code. So in case you want to change them, you can change them over here. Otherwise, you can use the defaults as well. The client ID and client secret need to be specified over here. It's not a good practice to put that into the code. And then you have the allowed client redirect URIs. We saw this in the code, and we've also specified them over here. All right. So that's how the environment variables file looks. In case you're pulling this code from GitHub, you can just directly only specify client ID and client secret. I think that should work because everything else has a default value already in the code. Thanks a lot for watching. So this basically completes the entire MCP client, the authorization server and the resource server setup that we did using Fast MCP. And I hope this helps you start with authentication for your MCP servers. Thanks a lot for watching again, and I'll see you next time.